Okay, so two things today. The first part is if I give you information, can you write an equation? Last lesson was all about graphing. This one's about now can you just write the equation? So there's two ways we're going to look at that first. If I give you a slope and a point, can you write the equation? Or if I just give you 2 points, can you write the equation? Okay. So kind of go back to the y equals mx plus b. In order to have an equation of a line, what two variables need to be numbers? The m and the b. So I would need the slope, which in this first case scenario, they give me the slope, so I have m. But what I don't have is the y-intercept, because I know the y-intercept is when x is 0, and none of these is when x is 0. Okay, but I know through my algebra skills, if I need a variable, such as b, and I have all of the other variables, I can then solve for the unknown, right? Through algebra. So look at the information they give me. They give me an m, a slope, an x, and a y. So I can sum all of those in. And the only thing I don't know is b. So I can use that information they give me, sub it in for the variables, and solve for b. Then once I have m and b, I can put m for m, b for b, and have the equation of the line. See how that works? Okay, so let's try the first one. So y equals, I always start with y equals mx plus b. A lot of you might be able to skip this step, which is great. I'm going to put my slope in for m, my x in for x, and this 5 in for y. So when you sub those in, I get this, which then I can just subtract 3 on both sides and have b. Now I have the m, which was up here in the beginning. I have the b, which I just solved for. So now I have the equation of the line. So my answer, y equals 3, because that's my slope, x plus 2, because I just solved for my b, my y-intercept. Try another one. So again, y equals mx plus b. I'm going to put the m in for m, x in for x, and the 12, that's my y, so I put that in for the y. So 12 equals 5 6 times 22 plus b. Okay. Now I'm going to help you use your graphing calculator today. Let's use that because this isn't very pretty, right? So let's use our graphing calculator today. So everyone turn your graphing calculator on. Okay. And this is what I want you to do. I want you to go parenthesis 5 divided by 6, close your parenthesis, times 22. Enter. And you should get like a decimal thing. Right now, go math, enter, enter. What'd you get for a fraction? 55 thirds, okay? And the reason we want to do that is when we start applying this and graphing at the same time, slopes need to be fraction form so you know rise over run. So to do this, we'd want to keep it as a fraction. Now you can use your graphing calculator again, because what you're going to do is subtract 55 thirds, right? So on your graphing calculator, you can go 12 minus parenthesis 55 divided by 3, close your parenthesis, equals, and then go math, enter, enter. Negative 19 thirds. That is a good answer right there, right? Learn to like fractions. I'm teaching you how to do it. So what's my answer then? My answer would be y equals my slope, which was up here, 5 6, and my intercept, which was 19/3. So use those graphing calculators today. Good? One more? So again, slope, here's my x, here's my y, there's my m. So y equals mx plus b. Put the y in for the y, m in for the m, x in for the x. 0 equals -3/5 times -4 plus b. And again, this might where you want to use the graphing calculator. If you can go ahead and do that in your head, that would be great, and just get 12/5. If you remember from your back to your 5th grade year how to do that. Some people just don't like fractions, I understand that. That's why I'm giving you the shortcut. So b equals -12/5. So then what's my answer? My answer, y equals my slope, -3/5 x, minus my b, which I just solved down here, -12/5. Simple enough? Not hard. Hopefully it's a review. Okay. The other part to this is just taking this same concept and just adding one more step to it. Okay. This one gave me the slope and a point. I need a slope and a point to find the equation of a line. So if I don't have a slope and a point, and I just have 2 points, how would I make these 2 points into a slope and a point? What did we learn on Wednesday? Very good. I can find a slope first from 2 points. So same thing we were just doing, only we're adding this first step of find the slope first, then sub stuff in to find b. So let's label here in case we forget our formula. x1, y1, x2, y2. My slope formula, if you remember, is y2 minus y1 over x2 minus a -10, right? Don't forget the double negatives. So this would be -8 over 8, which is -1. So my slope is -1. Okay? So before those problems, I had a slope and a point. I now have a slope and I have 2 points. It does not matter which point you pick to be x, y. Does not matter. Okay? What point do you want to use? First one? Okay? So I'm going to use this as my x and y when I'm subbing in. It does not matter. If you use the other point, you should still get the same b, the same y-intercept. So we're going to use this one. This is going to be my x. My slope was there, -1. And my y was 3. Okay, so 3 for the y, x for the x, m for the m. This is going to be a +10, so I'd subtract 10. So -7 is my b. So then I have an answer. I calculated the slope, so I have that, -x, and I also have a y-intercept, -7. So same thing, you just have to find m first. Not bad, right? Should we do another one? How about, I don't think do we have to do both of them, or just one more would be good? Maybe just one more? Okay, so let's jump to 18 just so we have negatives, because negatives are always harder. So step 1 again, we're going to calculate m. We need that slope. So here's x1, y1, x2, y2. So calculate 15 minus 10, y2 minus y1, x2 minus x1, double negative again, -6 minus a -4, which would be 5 over, add opposite, -2. So we got -5 halves. use a calculator, right? If negatives give you trouble, that's fine. So then I'm here at step 2, subbing in for my variables so I can solve for b. What point do you want to use? Any preference? Which one? Okay, this one, okay. So this is my x, this is my y, here's my m. So 10 equals -5 halves times -4. Right? And this is where you maybe want to use your graphing calculator again. That's fine. You should get 20 halves, which is 10. Right? If you did that in your calculator, or if you just did mental math, 5th grade, right? At multiply tops, multiply bottoms, 20 halves is 10. Subtract 10, and what happens to my b? It's 0. Right? It's 0. So how could you write that answer? You could write it with the slope, right? Like this plus 0. That wouldn't be wrong, but most of the time you would see it like this, just -5 halves x. Okay. But I like this problem, I like this example because here's a great question. How would I graph this? -5 halves x. Very good. This 0 means start at the origin. And then I would go down 5 over 2. Okay, so whenever your b is 0, that means you're starting at the origin and then doing your slope. Okay, so the next part, kind of going on another limb here in this section, is put slope-intercept form into standard form. So Wednesday, I gave you 2 steps, remember? I said move the x term, right? 99% of the time it's going to be move the x term, and then divide by the number in front of y. Remember that from Wednesday? Okay. So to then take, this puts standard form into slope-intercept form. So what standard form looks like is this, ax plus by equals c. And that's why we could say move the x term, divide by the number in front of y. So to then go backwards, slope-intercept form back into standard form, you're going to do these backwards. Okay. So the opposite of divide, of course, is multiply. So you look at your terms and you look to see if there's any fractions and anything in the denominator. So in this case, I have this 2. So whatever fraction denominator I have, I'm going to multiply everything by that number because that'll get rid of your fractions. So in this case, since I have this 2, I'm going to multiply everything by 2. Like that, everything by 2. So this 2 gets multiplied to the y, the 2 to the 1/2, which is 1, the 2 to the -2, which is -4. So the first step is get rid of all those fractions. Then you can move the x term back to the left side. So since this is a positive x, I can subtract the x back to the left side. So it would be -x plus 2y equals -4. And that's standard form, xy equals constant. Okay? So multiply if there's anything in the bottom, denominator, and then move the x term back. Okay. Let's try another one. So look at 23. Do I have any fraction, any denominator to worry about? No. So in this case, I can just go to that first step and just move the x term. So all I have to do is add the 7x back over to the left side and I'm done. Okay. So if there's no fractions, it's super easy. Okay. Well, let's look at another one with fractions like 24. So I look and see, oh, there's a fraction. What's in the denominator? 5. So I'm going to multiply every single thing times 5 to get rid of that. So the y, the x term, the constant, so 5y. What happens here is the 5's cancel out, and I just get -3x plus 15. right? Because multiplying by 5 and dividing by 5 cancel out. Then I can just add the x term back over to the left. So move that back over. So plus 3x plus 5y equals 15. And I guess you wouldn't have a plus sign there. And I threw that last example there just to show you that it's no different with decimals. Sometimes students just try to make decimals too complicated. You just look at those numbers. And is there any fractions to worry about? Nope, so all I do is move the x term over. That's all you're gonna do. So just move that over, negative 4.2x plus y equals 7.9. Okay, so that's just how to go back and forth between the two forms. Sometimes that needs to be done. What? All right, another way to graph a line is by intercepts, and the important part of the function is intercepts. Throughout the whole year, when we work on every function, linear, quadratic, polynomial, exponential, x and y intercepts are also always very important, and they always have some sort of meaning behind them. Okay? Like a quadratic, a parabola, what do the x-intercepts mean? It means starting, and then the ball got kicked in the air, and then it landed. Okay, they have meaning. So studying the x and y intercepts of graphs are very important, especially when you're doing realistic applications, like starting point, ending point. So let's just review quick what an x and y intercept are. So hold on the notes. This is my x-axis, this is my y-axis. So the point where it crosses the x-axis is called what? The x-intercept, very good. The point where it crosses the y-axis is then the y-intercept, very good, okay? So the important part to know, like definition, would be the x-intercept, y is 0. Because no matter where I have a point on the x-axis, y will always be 0, no matter what, negative 3, 0, right? This would be 8, 0. Y is always 0. That's the key information you need to know. X-intercept, y is 0. So then y-intercept, x is going to be 0. Because look, no matter where I have a point, that's 0, 9. Or that's 0, 6, right? Or that's negative 0, negative 1. Okay, no matter where I have a y-intercept, x is 0. So that's the key definition you need to know. X-intercept, y is 0, y-intercept, x is 0. Okay. So how does that help us? Well, we can use an equation in standard form and find both intercepts. Okay. So again, x-intercept is when what? Y is 0. So guess what I'm going to do? I'm going to sub 0 in for y and solve it. So that would give me 2x plus 5 times 0 equals negative 10. Well, anything times 0 is 0, so that term's just going to go away. So that leaves me with 2x equals negative 10. Divide by 2, x equals negative 5. That's my x-intercept point, negative 5, 0. And I can graph that. I can, on my x-axis, go 1, 2, 3, 4, 5, and put a point. Same thing for y-intercept. I know y-intercept, x is 0. So I put 0 in for the x now, which anything times 0 is 0, so that just goes away. 5y equals negative 10. Divide by 5, negative 2. So what's my point? 0, negative 2. And then I can graph that. 0, negative 2. It's crossing the y-axis. And those 2 points I can connect and graph my line. So you can graph your line slope-intercept form, but you can also do it by finding your intercepts. How about just one more of those, right? Let's do 29. Okay, so again, x-intercept, y-intercept, and some of you probably don't have to write all this work out. You can do it in your head. Go for it. If you can, go for it. That's great. Right, it'll save you some time. Okay, so x-intercept, definition, y is 0. So we're going to sub 0 in for the y there. But we know anything times 0 is 0. So this term goes completely away. It's gone. It's 0. So we get 5x equals 14. Divide by 5. My x-intercept is 14 fifths, 0. How do we graph 14 fifths? Well, 15 fifths is 3. So 14 fifths is going to be 2.9, 2.8. So I would go almost 3 on my x-axis. 1, 2, right? So like 2.8. And then y-intercept, x is 0, so again 0, right? So that's gone. Divide by 7. So my y-intercept then would be 0, 2. 14, 7 divided by is 2, right? So then I go up 2, put a point. Now those 2 points make my line, and I can connect them. Questions on that? Make sense? Okay. So the last part, parallel and perpendicular lines, hopefully from geometry. That sounds familiar. So let's take a second here, though, and review parallel lines. What makes parallel lines parallel? Who remembers? Right, they never cross. Okay, so then the big question is, why do they never cross? Very good. They have the exact same slope. So what you need to know about parallel lines, same slope. Good. What about perpendicular lines? What do we know about perpendicular lines? Very good. They intersect at a 90-degree angle. How do they intersect at a 90-degree angle? What about their slopes? Yep, they're opposite reciprocal. That means you change the sign, right? We can write it this way. Change the sign. So if it's positive, it becomes negative. Negative becomes positive. And flip it. Okay. So what's that mean if I had 3 halves as a slope? My perpendicular slope would be a negative 2/3. I would change the sign and I would flip it. Remember that from geometry? Or if not, maybe algebra 1. Does everybody have geometry in here? Yeah? Okay. Sometimes I get students going straight into algebra 2. Okay, so let's try a couple of these examples. So if you think back to the very beginning of the lesson, what 2 things did we need to make the equation of a line? Slope. And a point, right? Okay, you need a slope. I know it was so long ago. You need a slope and a point. So, and I need a point. Do I have a slope? If I want a parallel line to this line, my slope is going to be 2/5 because I know that the slopes are going to be the same. And then I also have a point. They say I want a line going through this point, 1, -1. So now, that was the only new part, because now I'm at the beginning of the lesson today, where if I have y equals mx plus b, I can put m for m, x for x, and y for y, and calculate b. Sorry, what? -1 equals 2/5 times 1 plus b. Subtract the 2/5 over. So I get -7/5. That's my b. Right? Because -1 would be -5/5, -5/5 minus 2/5, -7/5. Or use a calculator. Use a calculator, right? It's fine. So my answer then, a parallel line, of course, had the same slope, otherwise they wouldn't be parallel. But it cannot have the same y-intercept. Do not use that. No, no, no. You have to use this y-intercept. Otherwise, you would have the exact same line. You can't have the same y-intercept. Try a perpendicular one. So if I want a perpendicular slope, what would be the perpendicular slope on here? M would be what? Very good. Positive, because this is negative, so positive, and then 5/2. You flip it, right? We change the sign. Negative becomes positive, and I flip it. 2/5 becomes 5/2. So there's my slope. I have a point right here. Here's my xy point. So then, if I use y equals mx plus b, I can sub the x for x, y for y, m for m, and find the b. So 1 equals 5/2 times -3. 1 equals -15/2. So what would I do? I would add 15/2, which would be 17/2, because 15/2 plus 2/2, get a common denominator, would be 17/2. If you don't like it, use a calculator. It's fine. So my answer, y equals slope, 5/2, plus intercept, 17/2. What do you think? Got it? Want more examples of anything? The only difference on these ones down here is that the slope just isn't given to you. You would have to put it in slope-intercept form first, and then say, okay, there's my slope. So my perpendicular slope would be a positive 1/3. Because remember, you can put anything over 1. So negative becomes positive and then 1/3. So that's the only way it gets a little bit trickier, is you have to put it in slope-intercept form first to find the slope. And then you can use that with your x and y to find the equation.